Welcome to 6.1 Inverse Circular Functions. Now we are going to take a look at the inverse of cosine. So I started by graphing y equals cosine x, and we will see that this is not one-to-one because it fails the horizontal line test. So we need to restrict the domain, making sure that when we restrict the domain, we get all y values in between -1 and 1. Therefore, we will restrict the domain from 0 to pi. Now let's take a look at the inverse of cosine. So we could write this as y equals cosine inverse of x, or y equals arc cosine of x. Either way, this is saying find the angle whose cosine is x, or find the arc whose cosine is x. So we can write that as cosine of y equals x. Now we need to take the coordinates of the original function and switch them to give us coordinates of our inverse function. So 0, 1 will become 1, 0. Pi over 2, 0 will become 0 pi over 2. And pi -1 will become -1 pi. So this is the entire graph of y equals cosine inverse of x. Our regular function, y equals cosine x, continues on forever and ever. However, we have to restrict its domain to be able to find the inverse. Then when we go to graph the inverse, we are just restricted to this region right here. So our range is limited to 0 to pi. Let's look at our domain and range. Our domain is our x values. That's going to be -1 to 1. Notice that was the range of our original function. And our range is our y values. Those are 0 to pi. And notice that was our restricted domain of our original function. The point 1, 0 is our x-intercept, and our y-intercept is pi over 2, so the point 0 pi over 2 is our y-intercept. And this function is not symmetric to the y-axis nor the origin. So it's neither even nor odd. Example 2, find the value of the real number y in each equation. Notice when they say real number and we are talking about angles, it really means our answer must be in radians. So first, let's take a look at y equals arc cosine of 0. We can convert this into a regular cosine. What this is saying is find the arc whose cosine is 0, angle whose cosine is 0. Either way, we could write this as cosine of y equals 0. Because we are dealing with an arc cosine or an inverse cosine, because arc cosine is a function, we only can give one answer, and that answer must be 0 to pi. So where is our cosine 0? We are suspecting it's going to be at a quadrantal, so we might check each of our quadrantals. If our angle was 0, our quadrantal would be 1, 0. Oh, but cosine is the x value, so that doesn't have a cosine of 0. Let's try pi over 2. So here our coordinates are 0, 1. Aha! So we get y has to be pi over 2 because our cosine, or our x value, is 0. And notice that pi over 2 is in fact in between 0 and pi. B, y equals cosine inverse of 1/2. This is asking what angle has a cosine of 1/2? Or we can rewrite that as cosine y equals 1/2. Again, because I am finding a cosine inverse is a function, so I only get one answer. And because it's a cosine inverse, my answer must be 0 to pi. So where is cosine 1/2? It's going to be a 30 or a 60, and you might play around with it to figure out that it's a 60. We'll have a 60-degree reference angle, but we must give y in terms of radians. So 60 degrees is the same as pi over 3. I added c so we could do a cosine inverse of a negative. Let's convert. So we get cosine y equals negative rad 2 over 2. Because I'm looking for a cosine inverse, I know I need to be 0 to pi. Only one answer. And if cosine is negative, I must be in quadrant 2. Since my cosine is negative rad 2 over 2, I know we will have to be in quadrant 2 with a 45-degree reference angle or pi over 4 reference angle. So we could either figure out that that's 135 degrees, or noticing that that's a pi over 4 reference angle, since that's going to be 4 pi over 4, that's one less, or 3 pi over 4. Notice in all of these answers, for example 1 and example 2, we are only getting one value. When it's inverse cosine, those values will be in between 0 and pi. When it's inverse sine, it will be in between negative pi over 2 to pi over 2. I hope you enjoyed this video. See you next time.